take a look at Chapter 8, Section 3. It's Day 2 of Unit 8. Next class, when you come in, we'll do the practice, and hopefully we will get to the quiz on 8.1 through 8.3. So let's take a look at 8-3. We're going to look at quadratic equations. We have multiplied binomials using the FOIL method previously, and now we're going to factor trinomials to try and get them back to the form that they started in, and that'll make sense here in a second. And then we're also going to solve some equations in quadratic forms. The key is that today we're going to look at equations that are in this form up here, this x squared plus bx plus c. We're going to look at equations specifically in that format. So just some information here at the beginning, okay? And on this part, you're going to write down what you need, maybe the examples and things like that. Jot down some keywords, vocab, anything that's going to help you remember what is going on specifically. So last unit, we looked at 7-7. We learned how to multiply two binomials using FOIL. So for example, x plus 3 times x plus 4, and we would get x squared plus 4x plus 3x plus 12. And then 4x plus 3x is 7x, okay? What we need you to notice is that this middle term, 7x, is the sum of 3 and 4, and the last term, 12, is the product of 3 and 4. Okay, so this middle term, 7, we added the 3 and 4 to get it, and then this last term, 12, we multiplied the 3 and 4 to get that, okay? So you notice that the coefficient of the middle term is the sum. Let's go back up so you can see right here. So if we replace 3 and 4 with m and p, just random variables, okay? If we replace them, then we would notice that m plus p, or p plus m, that makes up that b term, and m times p makes up that c term, okay? So to factor trinomials that are in the form of x squared plus bx plus c, we're looking for two numbers that add to give us the middle term and multiply to give us the last term. So for example, here again, x squared plus 6x plus 8. 2 plus 4 is 6, and 2 times 4 is 8. And so that's how we get those terms, and that's how we factor. When c is positive, its factors have the same signs, okay? If c is positive, this term right here, then the two factors are either going to both be positive or both be negative. A negative times a negative makes a positive, and a positive times a positive makes a positive. So anytime c is positive, we know that these two signs right here are going to be the same. Okay? So far, so good. We are on page 485, so when we do examples, if the examples that I do aren't enough, feel free to go back and check out the personal tutor and get some more information. So taking a look here, this table right here, some of you will use this table a lot, and some of you will see this a couple times and be like, you know what, I don't need that table anymore. But this table here is useful. You can create a list basically of, for this problem, we have x squared plus 9x plus 20. So we're looking for factors of 20, and then you take the factors of 20, you add them, and we're looking for the two that add up to 9. So that's how we get 4 and 5. So x squared plus 9x plus 20 is the same as, or equal to, x plus 4 times x plus 5. Now the beauty of this unit, it's like we said in class, you'll be able to check your answers. If you take your answer that you got and use FOIL or the vertical method or the Punnett square or however you want, you can check your answer real easily and make sure that what you get down here is the same as what you started with up here. Okay? Let's take a look at an example. So here's how this is going to work. I'm going to do one example, and then you're going to pause the video and you're going to try the second example, and I will have the second example done for you to check your work. Okay? Let's take a look at this first one. So this first one, I'm looking for two numbers that multiply to 24. So you can make a chart or however you want to do it. Some people just I'm just going to make a list really. I have 24, so that's 1 and 24, 2 and 12, 3 and 8, or 4 and 6, okay? And then I'm going to add those all up. They add up to 25, 14, 11, and 10. So the ones that are 11, that's my answer, okay? 3 and 8. So when I go to write this out, I set up my parentheses. D times D is the only way to, look at this, the book made an error. That's D and that's an X. Let's go ahead and use X for both. Not my error, that's the book, kids. Alright, so let's see. We have X times X, that's how we get X squared. And then we use these two numbers, plus 3 and plus 8. Now some of you are asking, well, Mr. Emro, what if I wrote X plus 8 times X plus 3? Well, first of all, if you're asking me that, how could I possibly answer you? This is a YouTube video. And second of all, that's fine. That works because 2 times 3 equals 6, and 3 times 2 equals 6. So the order that we multiply them in doesn't matter, as long as you have one of those, x plus 3 times x plus 8, or x plus 8 times x plus 3. Now, on 1b, I am going to give you one hint that makes it easier. Let's change the order. Let's rewrite this as t squared plus 10t plus 9. Go ahead and pause the video right here, and then unpause it when you're done working the problem. Okay, hopefully you've tried the problem on your own. I'll show you what I got. I got t plus 9 and t plus 1. 9 times 1 is 9. 9 plus 1 is 10. All right, let's take a look at the next page. When factoring a trinomial in which b is negative, so this middle term, if this middle term here is negative and c is positive, the only way to do that is if we have negative factors, because we're multiplying to get this last term and adding to get this middle term, and the only combination of numbers that would let us multiply to a positive and add to a negative would be if they are both negative. So for example, on this one right here, we're going to look at negative factors of 12. So negative 1 times negative 12, negative 2 times negative 6, negative 3 times negative 4. Of those choices, negative 8 is negative 2 and negative 6. So now inside the parentheses, we end up with x minus 2 and x minus 6. The book is kind enough to show you here how you're able to go into your graphing calculator, and we'll look at this more specifically in class, but you can go into your graphing calculator, graph this quadratic. You can graph this and this on the same screen. If only one graph shows up, that means they're the same. And we'll look at that specifically in class and how to do that in both the TI and the Casio. Let's take a look at the example here. So just like what we just did, the only difference is that now we have some difference in sign. I'm going to rewrite this one so that it is m squared minus 22m plus 21. And then we're looking for factors of 21 that add up to negative 22. So we have negative 1 and negative 21, or negative 2 and negative, sorry, not negative 2, negative 3 and negative 7. Pretty simple here. Those add up to negative 22. So my answer is going to be m minus 1 and m minus 21. And that's it. Go ahead and pause the video right now. Take a second. Try to do this problem over here on the right, 2b, on your own. You didn't pause it, did you? Busted. Okay, let's take a look at what we have here. We have positive 28. So factors there are negative 1 and negative 28, negative 2 and negative 14, negative 4 and negative 7. And of those three, right here, negative 4 and negative 7, they add up to negative 11. So w minus 4 and w minus 7. And that's our answer. And again, you can always FOIL these answers or use the, use the vertical method if that's what you like. Check our answers. Negative 7 times negative 4 is 28. Negative 7w, negative 4w, w squared, and add straight down, and we get w squared minus 11w plus 28, which is exactly what we started with, so I know I'm doing it right. Let's take a look here. When c is negative, when this last term is negative, then it means the signs of the numbers are going to be different. One's going to be positive and one's going to be negative. The only way to get a negative number from multiplication is if we multiply a negative times a positive. These are probably the hardest variety because you're going to have to kind of play with the signs until you get them right. And so you're still doing the same thing. Here in this example, we're looking for two numbers that multiply to negative 15 but add to positive 2. So negative 3 plus 5 makes our positive 2. and it makes our negative 15. Okay, let's look at another example. Here we have x squared minus 7x minus 18, and the numbers here, these are our choices. Here the negative sign is actually bigger. When this is subtraction, the negative sign is going to be the larger number. So 2 times negative 9 makes negative 18, and 2 plus negative 9 is how we get our negative 7. Again, you can graph those to check your answer. Pretty simple. Some of you are going to be able to figure out how to graph it on your own. Some of you are going to want me to show you in class. On this one, I'm going to walk you through both because this is plus minus and this is minus minus. So I'll walk you through how to do both these. Some of you are ready to leave the chart, the negative 48. So that's, negative 1 and 48 and 2 and negative 24 and 6 and 8 and let's see, 3 goes in. How many times does 3 go in? 3 goes in 16 times. 3 and negative 16. And I notice right away that 3 and negative 16 is almost right. It's negative 3 and positive 16. Okay, now I'm really good at my times tables, and I'm really good at adding and subtracting integers, but you all have one of these thingies. So you feel free to use that whenever you need to. Okay, this becomes y minus 3 and y plus 16. And again, pretty easy to check. Negative 3y plus 16y is how I get positive 13y. And negative 3 times 16 is negative 48. Okay, let's take a look over here. Here we have a negative term in the middle, so we're looking for, this is negative 24, so I know the difference between the two is going to be, between the two numbers is going to be negative 2, so it's obviously not 1 and negative 24, that's too big. So let's try 4, negative 4 and 6. Well, they add up to 2, so what if I change it to 4 and negative 6? Good Lord. 4 and negative 6. Well, they add up to negative 2, and that's what I want. So we have r minus 4 plus 4, and r minus 6. And again, you're always welcome to check your work. Use whatever method you like, but that's r squared minus 2r minus 24. Let's take a look at a quadratic equation. This is very similar to what we did in 8-2, where we solved using the distributive property. The difference here is at the end, the zero product property still applies, so either that is 0 or that is 0. So we set the equation equal to 0. That's step 1. Always set equal to 0. Always. When solving a quadratic. Okay. Step 2 is to factor. In step 3, set each factor equal to 0 and solve. Okay. So step 1, they set it equal to 0. Step 2, we factored. Step 3 is take x minus 3, set it equal to 0, get 3. Take x plus 9, set it equal to 0, get negative 9. The nice thing about this is that you can substitute 3 into the original equation, and you should get something that's true. You should be able to substitute negative 9 into the equation, the original equation, and get something that's true. Okay? Let's take a look at an example here. So step 1, get it equal to 0. So I have z squared minus 3z minus 70 equals 0. And then I'm looking for two numbers that multiply to negative 70 but add to negative 3. So I know that's z minus 10 times z plus 7 equals 0. Z minus 10, positive 7. They add up to negative 3 and they multiply to negative 70. And then I'm going to take each one. Z minus 10 equals 0 and z plus 7 equals 0. So z equals 10 and z equals negative 7. So it equals both of them. Okay? Take a second, see if you can solve 4b on your own, and then we'll go over it. Pause. That's twice now. Alright, so let's take a look. We have x times, hopefully for negative 18 you got positive 6 and negative 3. So x should equal negative 6 and 3. Alright. Let's take a look here. Factoring can be useful when solving real-world problems. So Ling is designing a poster. The top of the poster is 4 inches, and the rest of the poster is 2 inches more than the width. Okay? If the poster requires 616 square inches of poster board, find the width W of the poster. So we're just looking for the width. Okay? We set up an equation. W equals W plus 6 equals 616. W squared plus 6W equals 616. So we get it equal to 0. We find the two numbers. And then down here we're going to have to use some common sense. The two answers here are W equals negative 28 and positive 22. Well, since a width can't be negative, we know that negative 28 is not the answer. So the width here is 22. If the width is 22 inches, then the area of the poster is 22 by 28. So that ends up being our answer, okay? Which is the amount the poster requires. Let's take a look down here at the bottom. The height of a parallelogram is 18 centimeters less than its base. If the area is 175 square centimeters, what is its height? I think I have a parallelogram in here somewhere. Here's a parallelogram. It's a little bit slanted. That's what you're probably more used to it looking like. The area formula for a parallelogram is base times height. Okay, so the height is straight down right there, and then that'd be h. Hopefully, it wouldn't be that curvy, and then that's the base. So if the height of the parallelogram is 18 centimeters less than the base, okay, so let's change these letters. Instead of using b and h, let's use the height is 18 less than the base. So we have b, and we have b minus 18. Okay. If the area is 175, what is its height? So what we have is 175 equals b times b minus 18. Okay. We end up with 175 equals b squared minus 18b. And then we're going to set it equal to 0. 0 equals b squared minus 18b minus 175. Okay, so now we need two numbers that are going to multiply to give us negative 175 and add to give us negative 18. When the numbers get bigger, it doesn't get more difficult. It just gets more tedious. We're going to have to go through and actually do some math. 25 seems like a logical thing. That should look like money. That should look like $1.75. Well, 25 is 7 quarters. So 25 and 7. If this is negative and that's positive, there's my negative 18 right there. Negative 25 plus 7 is negative 18. Negative 25 times 7 is negative 175. So I'm going to do b minus 25 and b plus 7. Okay. When we solve, we end up getting b equals 25 or negative 7. Well, since we're talking about length, we know that it's not negative 7. Okay? So the base is 25. The question asks for its height. If the base is 25, then the height is 7 centimeters. All right? That's it for the notes. Congratulations, you're done. See you in class. We'll do some practice, make sure we know what we're doing, and take the quiz. Have a great weekend. I can't wait to see you next time. Bye.